Hi, this is Dr. G. R. Sinha. We are going to talk about in this lecture sampling and mixing. These are the two processes, two states used in feedback amplifier. We need to understand how sampling and mixing are performed in any feedback amplifier. Let us see one block. This block I am writing it as A. It means this block is of an amplifier where A is, what is A? A is open loop gain because there is no closed loop. When we say feedback amplifier, there will be always closed loop. Whenever we say there is an open loop amplifier, there is no feedback at all. What is feedback? Feedback is a process in which some part of output is fed back to the input. How it is done? It will be always fed back through some network which we call here as feedback network. This feedback network connects output and input of the amplifier, and this beta is a feedback factor. What is beta? Beta is feedback factor. What is A? A is open loop gain. What we are interested in this topic is how sampling is done, how mixing is done. Now we need to understand what is sampling. Sampling is a process by which we take some output and send it to the feedback network. How will it do? How will we do this process? The sampling may be performed in two different ways. We can take output voltage and send this output voltage to the feedback network. How will we do this? We can send like this, that is plus minus, this VO can be brought. I mean the output voltage is V0 here, and this V0 is sent here to the feedback network. So what is sampled? We call it as sampled. What is sampled here? Something which is sampled is voltage. So what is sampling? What type of sampling it is? This is voltage sampling. This sampling is voltage sampling. Of course, there is a load resistance Rn across which output voltage V0 is being developed, and thus V0 is being sent to the feedback network. This type of sampling is called as voltage sampling. Now mixing. Mixing applies to the input. Now we understand whenever there is a feedback network, it produces some feedback signal. What is that feedback signal? This feedback signal will be, of course, beta times V0. Some part of output. What is the role of beta? What is the role of feedback network? Some part of output signal. And what is that part? Beta times V0. So beta times V0 is a feedback signal. Now, how do we mix this feedback component with the input signal? That is called as mixing process. We can mix this signal in series, and this can also be mixed in parallel. For example, this is the source voltage. We can draw here source signal also. Now, what is input voltage? Input voltage is here, which is sent to the amplifier. Now, if I mix this feedback signal like this, plus minus, we can see here the mixing is in series, because we know that in series voltages are added or voltages are mixed, and therefore we are writing this feedback signal as voltage signal. If the mixing is in parallel manner, the feedback signal will be current signal. And this is how we understand the concept of sampling and mixing in any feedback amplifier. What is sampling? Sampling is a process in which we sample the output signal. If the output signal being sampled is voltage, we call it as voltage sampling. If the output signal which is being sampled is current, we call it as current sampling. What is mixing? The feedback component is mixed with the input. In which manner? If it is mixed in series, called as series mixing. If it is mixed in parallel, it is called as shunt mixing. And accordingly, this is the basis by which we have four different topologies, four different feedback topologies. Feedback topologies are feedback topologies. First one is voltage series feedback. Voltage series feedback. We can see here, this is that example where the output signal is voltage, input signal is also voltage. Why? Mixing is in series manner. First topology is voltage series. Second will be voltage shunt mixing feedback. What will be the change? Output will be voltage. The mixing will be in parallel, and signal is mixed in parallel. This feedback signal will become current signal, and therefore the input signal will become current. Third topology will be current series. Current series. If the output signal which is sampled is current and mixing is done in series manner, so the input signal in this case will be voltage, and the last one will be current shunt. That is, the mixing will be in parallel manner. Here in current shunt, output signal is current, input signal is also current, and this will be a type of current amplifier. If you see the first amplifier, output is voltage, input is series, mixing is series, and therefore the input is voltage. So this is an example of voltage amplifier, voltage feedback amplifier. And this is how we can also classify the different topologies, different types of feedback amplifiers on the basis of what type of signal is being sampled and in which manner the feedback signal is mixed with the input. So this topic talks about sampling, the process by which output is sent to the input, to the feedback network, and how the feedback component is mixed with the input, what we call as mixing. And the sampling and mixing are the two important steps or stages or processes which is responsible in classification of different types of feedback topologies, different types of feedback amplifiers. Hope this will help the learners in identifying and in classifying different types of feedback present in different types of amplifiers. Thank you.